In Module 3, we're going to explore a few more classroom strategies that you will be using that really help you get to that transdisciplinary teaching. Effective transdisciplinary teaching is really important to explore in order to understand how to pose an appropriate STEAM problem scenario, which we're going to be working on. One goal is to create an authentic STEAM scenario. So what does it mean to have an authentic STEAM scenario? This means that it's something that's real world. It can be contextualized to situations or to issues that students can understand. So thinking about your students, the age of their students, and what some are the issues that they're interested in and can understand is really important. It needs to be both important and plausible. The plausible component is really critical, especially as kids get older. They'll understand if a problem can really be solved by them or if it's something that you just posed. And present an issue with one or more problems to be solved. So this is not just having one solution at the end, but that there are multiple ways to solve the problem. This really helps to make it authentic because all real-world problems have multiple ways to solve it. As we've talked about problem-based learning, we're going to tease this apart a little bit so you can kind of understand what it'll look like in the classroom. So problem-based learning is that it's student-centered and inquiry-based. Remembering that inquiry-based means that at the end of the unit, students will have a lot more questions than answered. It's an ill-structured problem. What this means is that it's not easily solved by a specific answer. So we often call it ill-structured in that it's an unstructured problem. Problem-based learning incorporates collaboration, inquiry, and technology that all guide the problem-solving process. The instructional design, it's really important to think about identifying the outcomes that align with your standards. And then, when you think about designing this scenario, think about those standards and the problem and how you can build it out and really make it real world. One way is to introduce the problem and to brainstorm about how you would actually solve this. That sometimes helps to give teachers ideas about which pathways students would take. Students will then often conduct collaborative research, but they'll also participate in activities such as small investigations, right, where they're going to be collecting data or surveying people. And then students should present solutions and do some peer and self-assessment. The key is to present a quality problem scenario. But don't worry, in this class we're going to be doing lots of revision and we'll have time to make sure that your problem scenario is quality. But because this is how the entire unit is built upon, if you don't have a quality problem scenario, it's really difficult to have a great unit come out of it. Another important component is to make connections to skills and jobs. One of the reasons, if you'll think back to the first class, that we even do STEAM education is to help students consider new skills and jobs, such as urban planning, public relations, an epidemiologist, a landscape architect, project directors, vet techs, or horticulturists. All of these jobs are available to our students today, and we want them to think about that they can have a place in developing these skills. When you create your STEAM unit plan, we like to think about it in 3 steps. So begin with an outline of standards-based unit with a problem-solving scenario and driving question. We already got a good start on that in the last course, so you're going to want to refer back to that. You'll receive instructor feedback from me, and then you'll add additional resources, mentors, and experts. And then in Module 4, you will provide one another with peer feedback and refine your unit. This is really important to both model and to practice the peer feedback and to make sure that you have the best unit that you can.